Today we're covering 7.2, which is graphing rational functions. So the parent function, f of x equals 1 over x, is a hyperbola, okay? So a hyperbola consists of two symmetrical parts. These two parts are each called branches. So there are two separate branches. On the parent function 1 over x, the two branches occur in quadrants 1 and quadrants 3. But with different transformations applied, they can move and occur in different places. So the domain and the range are all non-zero real numbers. Typically, we are going to go ahead and write it as all real numbers, and then x is not equal to 0. That would be your domain, and all real numbers, and y is not equal to 0 would be your range. So any function of the same form with a number on top and an x on the bottom is going to have the same asymptotes, domain, and range as the function 1 over x. Now, so that is if it has a vertical stretch applied or a vertical shrink, but we're going to learn about transformations later on. So notice that they have asymptotes here. At x equals 0 is y equals 0 is the horizontal asymptote, and x equals 0 is the vertical asymptote. Okay. So, graphing a rational function in this form. It says to graph the function g of x equals 6 over x. And it does want us to compare to the graph of 1 over x. So, we can either by hand or using a calculator come up with a table of some points. I probably do more points than is necessary just to get a feel for the curve. So for the parent function, the points I did negative half, negative 1, and negative 2 for one branch, and then 0.5, 1, and 2 for the other branch. And these are the y values I got. So once again, you can plug in the x's to find the y's or use a calculator to find them. I typically do them by hand, just to prepare for a no calculator portion. All right, so where this branch occurs is right here. And that's the branch down in the third quadrant. And then it has a symmetrical branch that occurs also up here in the first quadrant. And that's the parent function, the 1 over x. Okay, so then the other function, g of x equals 6 over x. I came up with these points. So I used numbers that divided nicely with 6. I used negative 3, negative 6, and negative 12. So I got negative 2, negative 1, and negative 1/2. And then I used 3, 6, and 12 for the other branch, and I got 2, 1, and 1/2. All right, let's take a look where those are. They kind of hung off the edge. I eventually went back and filled in some other points, to be honest. So like negative 3, negative 2, that one's right here. And then we had negative 6, negative 1, that was up here. I also had negative 1, negative 6. So like I said, I kind of filled in some points to get that curve. All right, and so then over here I did the same thing. So I had 3, 2. I also had 2, 3, 1, 6, 6, 1, and those fit nicely on this graph that they gave me. So it says compare the graph, okay? So first of all, the graph is a vertical stretch by a factor of 6, but also what they're looking for is not just describing the transformations, but actually comparing it. So the graph of g of x is further from the axes. So if you look at the graph right here, g of x is further from the x and the y-axis than the original graph. Both graphs are in quadrants 1 and 3. And they both have asymptotes at x equals 0 and y equals 0, which means they both have a domain of all real numbers, but x is not 0. And they both have a range of all real numbers, but y not equal to 0. So that's really what they're looking for when they say compare. Okay, so on this one, they want us to graph g of x is negative 6 over x and compare it to the original. So I'm going to go ahead just real quick and graph these same points that I had graphed for 1 over x, the parent function that I had graphed previously. So let's see here. Those were right here. So it's kind of a small graph, but we can see this branch is pretty close to the x and y axis. It has points, the same points we had in our table on our previous example. You can just refer back to. All right, so there is our graph of 1 over x. Okay, so I did that one in blue. So now let's go ahead, let's make a table for negative 6 over x. All right, so once again, I probably did more points than I really needed to, and I picked points that went in nicely. So I did negative 6 is at 1, negative 3 is at 2, negative 2 is at 3, and negative 1 is at 6. Okay, so if we graph those points, we're going to see that they are occurring up here in the second quadrant. So I have these points that we had listed off previously. All right. And then I'm also going to need points for the other branch. So for those, I went ahead and I graphed, let's see here, 1, 2, 3, and 6. And so those gave me these y values. So if we go ahead and graph those, remember it's going to be symmetrical, so a lot of times you can just come up with them without, figuring out mentally over and over. And so the reason I'm graphing more points than usual is because I'm trying to get a good curve on both branches. Okay, so now it says to compare. So the first thing is just straight up the transformations are, it was a reflection over the x-axis, and it was a vertical stretch by 6. But they also want us to talk about the actual graph. So g of x lies further from the axis than f of x. That's from the vertical stretch. Notice that g of x is in quadrants 2 and 4, which is due to the reflection. Let's see here. The asymptotes, the domain, and the range are the same. So the asymptotes are still x equals 0, y equals 0, and then that causes the domain and the range to be the same also. Okay, so this is now looking at graphing a translation. So when we have it written like this, it's actually really easy to figure out what the translation is. So first of all, we have a right down in the bottom. You see this x minus 1. So that is going to be a translation right 1. Okay, keep in mind our order. Next, we have a vertical stretch by 2. The negative causes us to have a reflection in the x-axis. And then the plus 3 causes us to go up 3. So what that tells me, just in general, is that I'm moving this asymptote to the right 1. I'm moving another asymptote up 3. The stretch is going to cause it to be farther from the axis, or in this case, farther from the asymptotes. And the reflection is going to cause it to land in quadrants. I guess not technically quadrants, but the upper left-hand corner of the intersection of the two asymptotes and the bottom right-hand corner of where the two asymptotes are. So once again, we can go ahead and we can get actual points. So I did that in a calculator. I got the points negative 3 up 3.5. Let's see here, negative 1 up 4, and I did 0, 5. So good enough to get my curve here. I'm going to go ahead and also draw in my asymptotes on this graph. So here's my horizontal asymptote at 3, and here's my vertical asymptote at 1. All right, and then the points for the other branch, I did 2, 1, 3, 2, and 5 was at 2.5. All right, and then it says state the domain, range, and asymptotes. Well, so your horizontal asymptote is at y equals 3. Your vertical asymptote is at x equals 1. Your domain is all real numbers except x is not equal to 1. And your range is all real numbers except y is not equal to 3. Okay, go ahead and press pause and do the monitoring progress if you feel like you need the practice. And then in just a minute, I will show you the answer to that question. Okay, so here's the solution to the monitoring progress. Okay, so the next thing we're going to do is we're going to look at graphing other rational functions. So rational functions of this form, y equals ax plus b over cx plus d. So those forms also have graphs that are hyperbolas. Okay, so to find the two asymptotes is actually pretty easy. So first of all, the vertical asymptote of the graph, how we're going to go ahead and find that is this explains a whole strategy, but honestly, I think it's more intuitive to set the denominator equal to 0 because that's where it's going to be undefined. So set the denominator equal to 0 and solve for x. And so this is the vertical asymptote. All right, so just to show you that real quick down here, on this equation on example 3, the denominator is x minus 3. So when that denominator is 0, it's going to be undefined. So if you set the denominator equal to 0 and solve, you get x equals 3. So this is going to be your vertical asymptote. And we'll just go ahead and draw that on there real quick, and then we'll go back up to the top and we'll figure out how to find the horizontal asymptote. Okay. So how you find the horizontal asymptote is, it says you just find the line y equals a over c. A is the coefficient in front of x on the numerator, and c is the coefficient in front of x on the denominator. So in this case, a is going to be the 2 with the x, and then b is going to be this 1. So it's going to be 2 over 1, which tells us y equals 2 is the horizontal asymptote. So let's draw that one in also. Okay, so I went ahead and you could do this by hand. I pulled this up in my graphing calculator. So I did a set of points. So at -4, it's at 1. And at 0, it was at -1/3. At 1, it was at -1.5. And at 2, it was at -5. So that's that branch. We'll go ahead and draw it in. And then the other branch was at 4, it was at 9. And then at 5, it was at 5.5. 6 is at 4 1/3. And at 10, it was at 3. So that got me that branch. And then it wants me, I've already stated my asymptotes, but it wants me to do the domain and the range. So the domain is all real numbers, except x cannot be equal to 3. And the range is all real numbers, except y cannot be equal to 2. Okay, so go ahead and press pause if you want to do the monitoring progress. I will have you do that, and then I will come back on and show you the correct answer. Okay, so here's the answering to this monitoring progress. Vertical asymptote is at x equal to -2. Oops, I'm sorry. This is the horizontal asymptote. Is at y equals 3. And then the domain is all real numbers. X is not equal to -2. And the range is all real numbers. Y is not equal to 3. And then you have our graph.